Most developers, they're stuck in a trap. They think that to create something real, they need to download 40 gigabytes of game engine data, navigate a bloated UI, and drag and drop their way to finished product. But when you do that, you aren't a creator, you're a tenant. You're living in someone else's architecture. Today, I'm moving back to the raw metal. I'm going to show you how to architect a high-performance, visceral game engine using nothing but C++ and the Qt framework. Along with that will be a simple ASCII characters. We aren't just making a game. We're building a system. We're going to talk about momentum physics, particle life cycles, and how to create some juice. Juice that has an intangible feeling of weight and impact. Using nothing but logic. Time to stop acting like a student, following a how-to guide. It's time to start acting like an architect. Every great structure, it starts with a foundation. In this project, our foundation isn't a terminal. It's the QGraphicsScene. Well, I'm going to use this because terminals are restricted to the refresh rates of the OS buffer. If we want 60 frames per second, 60 frames per second of buttery-smooth action, we need to dedicate a graphics pipeline. Notice the cell size constant. We weren't working with pixels. If we were, we'd be working in a coordinate grid. This allows us to abstract the logic. If we decide to move from a small window to 4K display, we don't need to change the game logic. We just need to change the scale of the cell. But look at the star field initialization. I'm spawning 80 stars. Each star just isn't a static point. It's a phase of a glimmer speed. By using a simple sine wave, the sine wave on the alpha channel later in the render loop will make the background breathe. Think about the math of the glimmer. We're using a specific formula where the alpha creates 100 plus 100 times the sine of the phase. This ensures the stars never fully disappear, but they pulse in a way that feels organic. Never let your background be truly static. Even the subtle glimmer, it tells the player the world is still alive. It's still alive before they even move. It's about subconscious engagement through the environmental feedback. Let's talk about the ship. In a professor-style tutorial, you just add X and Y coordinates. When the key is pressed, well, it's going to move around a little bit, but it makes it feel terrible. It feels like moving a cursor on a screen. Instead, we've architected a momentum decay system. Look at these lines. Player dx, that's going to multiply 0.97f. F is for float. And the dy will also multiply 97 float. Every single frame, we're stripping away 3% of the ship's velocity. This is the secret. It creates the illusion of space. When you thrust with W, you're adding the delta, but when you decay, it's always fighting you. Notice how we calculate the movement. We take the player's angle, convert it to radians, and use the cosine of the angle for the x-axis, and the sine of the angle for the y-axis. Both multiplied in our thrust value. This is the fundamental math of every AAA game engine, from asteroids to the starfield. By doing this manually, you understand the relationship between the rotation and the direction. You aren't just calling a pre-built function. You're calculating the actual trajectory of an object in 2D space. We also implement the thrust combo system. If you tap the thrust quickly, a reset timer gives you a multiplier. We're rewarding the player for skillful timing. This isn't just math. It's a real game feel. A game without consequence, it's boring. The architecture of destruction here relies on two systems, a recursive splitting and a particle decay. When the bullet intersects the asteroid, we use a Euclidean distance check But let's take a look at the code for the split. If an asteroid's size is greater than the specific threshold, well, I don't just delete it. We spawn a new smaller entities in the same location, but with random trajectories. This in turn, this is going to create a fractal. A fractal that will feel the combat. Notice the loop. The loop where we update the bullets. We have to decrement an iterator after removing the item. This is a critical architectural detail. When you remove an item from the list while iterating over it, the list shifts. If you don't handle that index shift, everything will crash or it'll skip to the next object. In building this system, I want to build it so that it's robust enough to handle its own data mutations without skipping a beat. Now we have to consider the particles. This is where the incredible animation happens. Every explosion spawns 12 entities using a simple dot symbol. These aren't permanent objects. They do need a lifetime. In the renderer loop, we calculate the transparency based on how much life they have left. This creates a fade out. The fade out effect, it gives the player's action and weight. When you clear the screen, the remnants of your battle literally fades into the stars. It's elegant, it's memory efficient, and it looks really cool. How do we make ASCII characters feel dangerous? Well, it's time to use some juice. Look at the damage timer. When the player hits the asteroid, we trigger a 20-frame shake. It's a shake state in which it's time to generate a random offset and apply it to the rendering position. To the player, it feels like a physical impact. Combined with the ship's color shifting to red, we're communicating danger. The danger is communicated through color and movement. It's also communicated with the UI simultaneously. Even the level progression, well, that's architected to escalate. We aren't just spawning more rocks. We're changing the capabilities of the player. At level 2, let's change the color for visual feedback. At level 3, we enable a triple shot. At level 5, we increase the thrust multiplier. This is essentially a finite state machine. By changing these booleans and multipliers, we change the rules. We change the rules of the world as the player moves through it. This is how you build scalability. Today it's a triple shot. Tomorrow, well, the same architecture, it can be applied to shields or warp drives. What we've built here isn't just a clone of the 80s arcade game. It's a testament to what happens when you stop looking for the easy way and start looking for the right way. By building this engine from scratch in C++, well, we've learned about physics, render loops, and memory management. More so than you would ever do dragging a prefab into a modern engine. As an architect, your job is to understand the soul of the machine. That's what C++ does well. Whether you're using ASCII or 4K textures, the logic remains the same. If you can make a simple dot feel like a star and a triangle feel like a starship, you can build anything. Thank you for watching. Please leave thoughts, comments, and let's build the future of development together. Remember, happy coding!